Gemini 3.6 Flash and Gemma 4 are going head to head right now. And the gap between them is more interesting than the headlines let on. Gemma 4 hit 192 milliseconds time to first token on LiveKit's stack, and that number shifts the whole conversation. Both models dropped recently, and teams are actively picking between them right now. We ran Gemini 3.6 Flash versus Gemma 4 across 4 real tests: speed, reasoning, deployment, and cost. All sourced from verified data, no vendor spin, no made-up scores. Gemma 4 wins more rounds on paper, but the model that actually fits your team might not be the one with the higher score. And that gap matters when you're the one shipping. This comparison is for developers and teams who need to pick one and ship. Building agentic pipelines, voice AI, or anything with real privacy requirements means the wrong choice costs you real money and real time. We pulled from 15 verified sources and 24 data points, so you don't have to do this yourself. This test 1, inference speed and latency. Slow responses kill user experience. And in voice AI or agentic workflows, every extra millisecond adds up fast. Video is the first thing users feel, and a brilliant model that makes them wait still loses. Gemma 4 on LiveKit stack hit 192 milliseconds TTFT, and on Cerebras, it clocked 1851 tokens per second. Gemini 3.6 Flash has no published TTFT figure at all. These are different test setups, so it's not a clean one-to-one comparison, and Gemini does use 17% fewer output tokens per task, which helps its effective speed. Gemma 4 takes this test. The published speed numbers all belong to Gemma 4. And Gemini 3.6 Flash has no equivalent figures to compete with, putting the score at Gemini 3.6 Flash 0, Gemma 4 1. First point goes to the open weight model, and it wasn't particularly close on the raw data. This one is messier than the score suggests. Gemma 4's numbers came from Cerebras and LiveKit, which are heavily optimized setups most teams won't replicate on standard GPU hardware. Gemini 3.6 Flash's token efficiency partially closes the gap in practice, so your real-world experience may land much closer than a raw millisecond comparison implies. Test 2, reasoning and coding accuracy. This is the one that matters if you're using AI to write or debug code, solve math problems, or run multi-step logic. A fast model that gets the answer wrong is worse than useless in production. And accuracy here translates directly to how much you trust the output. Gemini 3.6 Flash scored 49% on deep SOE coding, up from 37% on the previous version, which is a real jump. Gemma 4 hit 0.675 weighted accuracy across ARC Challenge, GSM 8K, and Truthful QA in an ArcSIF study. Neither model has published scores on the other's benchmarks, so you're comparing apples to something that isn't even a fruit. This test is a tie too close to call. The benchmarks don't overlap enough to name a winner, and picking one based on different test suites would just be making stuff up. So the score stays at Gemini 3.6 Flash 0, Gemma 4 1, with one tied. The accuracy round goes to nobody, and that's the honest answer. Both models are genuinely strong in their own lane. Gemini 3.6 Flash's deep SOE jump is the clearest single accuracy gain in all the evidence. And Gemma 4's ArcSIF result is the most independently validated number in this whole comparison. They just tested different things, so the gap between them is unknown, not necessarily large. Test 3, deployment flexibility. Where and how you can run a model determines whether it even fits your project. Working in a regulated industry or simply keeping data off third-party servers narrows your options fast, and flexibility here is a hard requirement for a lot of teams. Gemma 4 runs locally via Olama, LM Studio, Llama.cpp, and MLX, and also on-premise, air-gapped, on-edge devices, and in the cloud. All under Apache 2.0. Gemini 3.6 Flash is cloud OPI only, full stop, with no weights published and no local option. One model gives you full control, the other gives you a managed endpoint. Gemma 4 takes this test, and it's not a contest. 4 model sizes, Apache 2.0 license, local and air-gapped support, edge deployment. The whole package puts us at Gemini 3.6 Flash 0. Gemma 4 2, one tied. Deployment flexibility is where Gemma 4 really pulled away. Test 4, cost per million tokens. At scale, the difference between two models can be thousands of dollars a month. And if you're running agentic pipelines firing off hundreds of calls a day, pricing is one of the first things you need to nail before you commit. Gemini 3.6 Flash runs at $1.50 per million input tokens and $7.50 per million output tokens. Verify. Gemma 4 on LiveKit inference came in at $1.20 per million output tokens, which is a substantial gap, though that's one specific deployment, not a universal Gemma 4 price. Self-hosted Gemma 4 eliminates the per token fee entirely, which flips the math completely at scale. Gemma 4 takes this test because whether you self-host or use a managed option, the per token cost comes out lower than Gemini 3.6 Flash's published API rate. That brings us to Gemini 3.6 Flash 0, Gemma 4 3, one tied. With Gemma 4 having won all 3 decided rounds, the cost story has real texture to it, Gemini 3.6 Flash's cached input rate drops to 15 cents per million, a 90% discount, which is genuinely useful for agentic pipelines resending the same system prompt repeatedly. Small teams without GPU capacity may actually pay less with Gemini's API than standing up their own Gemma 4 infrastructure. So run your own numbers before you decide. Gemini 3.6 Flash wins on convenience and agentic coding efficiency. One API key and you're in production, no GPU provisioning, no ops work. Its DeepSWB score jumped from 37% to 49% using 65% fewer output tokens, cutting agentic coding costs hard, and that 90% cached input discount makes repeated large prompt calls far cheaper per run than the sticker price suggests. Gemma 4 wins on freedom and cost at scale. Apache 2.0 open weights mean your data stays on your hardware, full stop, and 4 model sizes from 2.3 billion to 31 billion parameters. Cover everything from mobile to high-end servers. Self-hosted deployments eliminate the per token fee entirely, and even on managed endpoints, $1.20 per million output tokens beats Gemini 3.6 Flash's $7.50 rate. The decision comes down to how you run your stack. If you need a managed API that just works, strong agentic coding performance, and zero infrastructure overhead, go with Gemini 3.6 Flash. If you need local deployment, air-gapped privacy, lower cost at scale, or flexibility across device sizes, Gemma 4 is your answer.